We're resuming page 20 of the Financial Mathematics booklet, where today we're going to be starting to evaluate a sigma notation or sum of 5k minus 1 from k being 3 all the way to 20. So we're going to substitute in the 3 first into k, giving us 5 times 3 minus 1, which is 14. Then we're going to plus that with 5 times 4 minus 1, which is 19, and so forth. And if I substitute in now 20 as k, 5 times 20 minus 1 is 99. So now we're going to sum all these numbers here. And remember we had two formulas, which is n over 2 a plus l if we have the last term, and n over 2 2a plus n minus 1d if we had the first term and the common difference. So in this case, we do have the last term, so we're going to use this formula. Okay. Now, how many terms do we have? Well, we substituted in 3 all the way to 20. So if we get the number 20 minus 3 plus 1, we do get 18 terms. Okay, so this is from the time we substituted in 3 all the way to 20 inclusive, so that's 18 terms. So n is going to be 18. So we're going to find S18 using this formula. So 18 over 2 square bracket a, which is 14, plus l, which is 99. Okay. So if I do that on my calculator, I do get 1017. That's the sum of all those numbers. Question 7. Find an expression to the sum of the n terms of this series. Okay, so we don't know how many terms there are, but it just says there's n terms. A is going to be 6, whereas D is 56. Oh no, it's not, it's 50. This is going up by 50, right? So we've got A and D. We don't have the last term, so we have to use this formula to help us. So Sn is equal to n over 2, and then 2a, which is 2 times 6, plus n minus 1d, and d is 50. So we get n over 2, 2 times 6 is 12, plus 50n minus 50. Now, if I get 12 minus 50, that would get me negative 38. And so if we multiply by n and also divide by 2 to each of these, we do get 25n squared minus 19n. And that will be our sum formula to n terms. Okay? Meaning that if I substitute in 1 in here, I'll get 6. If I substitute in 2 in here, I'll get the sum of these two numbers, which is 62. If I substitute in 3, I'll get all these three added together. So it's a nice formula for us to get a sum straight away. Next off, question 8. So, for question 8, find expression for the sum to n terms of an arithmetic series with first term 2 and a common difference 8. So it's exactly the same thing as before. We're going to do Sn equals n over 2, and then a is going to be 2, whereas d is 8. So we sub back into this formula. So we'll do 2 times 2 plus n minus 1d, which is 8. And if we simplify, we get 4 plus, well, this is going to be 8n minus 8. Simplifying that down. Okay, let me move this away. We'll get Sn, sum to n terms, is n over 2. 4 minus 8 is going to be negative 4, so 8n negative 4 will be what's resulting in that square bracket. Then we're going to multiply by n and also divide by 2 to each of these, giving us 4n squared minus 2n, and that's S of n. Now we got to find out the number of terms in the series if the sum was 870. So the sum is 870, meaning we have to put it in here. So 870 is going to be equal to 4n squared minus 2n. The coefficients of n squared and n, and as well as this number, are all divided by 2. So we can divide them by 2 and get 435 equals 2n squared minus n, and then move the 435 over to create a quadratic that is equal to 0. Okay? Now, we're going to use the quadratic formula because these numbers are pretty large for us to figure out factors of. So we'll do n equals to negative of negative 1, that's the b value, plus minus the square root of negative 1 squared minus 4 times 2 times negative 435 all over 2a, which is 2 times 2. So if I do 1 minus 4 times 2 times negative 435, I get root 3481, and then if I simplify that, I get 2 plus minus 59 over 4. Now just notice how we're finding the number of terms, which is going to be a positive value, so we're not going to have that negative being there. We'll just substitute in the positive one in there. So if I have 2 plus 59 divided by 4, oh, okay, something's wrong here. I get 15.25. Let me just double check what's wrong here. 1 sec, girls. So that's right. Okay, I've equated with 870. I divided by 2 and I got this. Everything seems okay. Oh, why did I get 2 here? This should be a 1. So sorry about that. There's a 1 there. So this will be 1 plus minus 59. And so if I get 1 plus 59 divided by 4, it should equal to 15. There we go. Okay, I just made a very simple error. Sorry about that, girls. So there's 15 terms that we have to add together in order for the sum of those 15 terms to be 870. Done. All right. In the next scenario, given Sn, find T of n. So this means that if we have n terms, we can find out what the term formula that generates each number is. So let's have a look at the first example. The sum to the first n terms is 100, and the sum of the first 9 terms is 81. What is the 10th term? The first thing you'll notice is that 10 terms looks like this, which is equals 100, and then 9 terms is just one less term than this whole bunch, and that equals to 81. Okay? So if I get this equation here minus the second equation here, T1 will cancel, T2 will cancel, everything will cancel up to T9, okay? Meaning that I'll have T10 left minus 0, which is T10, or the 10th term, and that equals to 100 minus 81, which is going to be 19, okay? So if we generalize this, that means that whatever term we want at the end, okay, of the sum up to n terms, so this is, S10, this is S9, okay, Tn, which is in this case T10, okay, Tn is going to equal to the sum of n terms, which we put S10 for, minus the sum of one less term, which is the sum of 9, okay? So this is a formula that we have to use all the time, all right, and it always works. So, say for example, 1, if Sn is n squared minus 2n plus 3, and that's the formula that you get to sum up any number of terms, let's find a formula that generates each term, okay? So, Sn in this case is n squared minus 2n plus 3, and if we substitute in n minus 1, we get n minus 1 squared minus 2 times n minus 1 plus 3. Expanding this out gives us n squared minus 2n plus 1 minus 2n plus 2 plus 3. n squared minus 4n plus 1 plus 2 plus 3 would be plus 6, okay? And so if we wanted to find out the term formula, we get the sum to n terms subtracted by the sum of 1 less than n terms, which is that. N squared minus 2n plus 3 minus n squared minus 4n plus 6 will be n squared minus 2n plus 3 minus n squared plus 4n minus 6. The n squares cancel. Negative 2n plus 4n is going to give us 2n, and 3 minus 6 give us negative 3. So there's our formula that will generate any kind of term in the series. And we have to finally find out what is the 41st term. So we substitute in 41 into n. So that will give us 2 times 41 minus 3. 2 times 41 minus 3 would give us 79. So 41st term is 79. Moving on. Right. Question 1 is going to be exactly the same thing. Okay, so sum to n terms of an arithmetic series is given by this. We're going to find the sum to 9 terms. So substitute in n is 9. So we get 120 times 9 minus 3 times 9 squared. So 120 times 9 minus 3 times 9 squared will be 837. And the 9th term is going to be T9 equals to S of 9, so the sum to 9 terms, minus the sum of one less term. Okay? So, S9 is already 837. We just found that out. But we don't know S8. But we can substitute this back in here to get what S8 is. So let's do that. We'll substitute it into n as 8, and also write this in brackets because we want to minus this whole thing. So we put that in brackets. And what we'll end up getting is number 69. So 9th term is 69. Question 2. The sum to n terms of an arithmetic series is 5n squared plus 2n. Find expression for the nth term. So Tn is S of n minus S of n minus 1. So the sum to n terms is 5n squared plus 2n. And we're going to subtract that by square bracket. And we're going to start to replace n by n minus 1. So that's 5 times n minus 1 squared plus 2 times n minus 1. I simplify my working out by firstly expanding what this is and that. So I'll have 5 times n squared minus 2n plus 1 plus 2n minus 2. I expand that 5 further in with the round bracket. So I'll have 5n squared minus 10n plus 5 plus by 2n minus 2. So that, once I simplify all this, I will get 5n squared minus 8n, 5 and minus 2, subtract to give you 3. Okay, let's do this all in one go now. 5n squared subtracted by 5n squared will cancel, so that goes away. 2n minus 8n, which is plus 8n, is going to give us 10n. And the subtraction of a positive 3 is just minus 3. And that's your nth term formula for that. There we go. Let's move on. All right. So now what I've done is I've put some mixed AP questions. Let's revise all our formulas again. The term formula is a plus n minus 1d. Your sum formula comes in two different forms, so a plus l times n minus 2, and n over 2, 2a plus n minus 1d. There we go. So, the thing is, how do you actually know this is AP? It's very hard to tell because you don't see the same denominators. But once you change the same denominators, it'll be fine. The lowest common multiple of these denominators here is 6. Half is the same thing as 3 over 6. 2 over 3 is the same thing as 4 over 6. And then the next one is 5 over 6. And now you can see that it goes up by 1 over 6. Okay, so that's your D value. Whereas A is just 3 over 6, or half. So if you want the 22nd term, and you're using this formula, well, T22 is going to give us A, which is 3 over 6. We can write half if you want, plus 22 minus 1, D, and D in this case is 1/6. Okay? What you'll end up getting in your calculator once you type it in is the number 4. The sum of the first 22 terms, okay, allows you to pick from either these two equations. Okay, so the formula that we're going to use is this one, because if we're summing the first 22 terms, well, we do have the 22nd term, which is the last term of this series, so we can use this formula. So, S of 22 is going to equal to 22 over 2, and first plus last term would be, well, half, right there, plus by the last term, which is number 4. Okay, and that will give us an answer of 49.5. Question 2. The 17th term of the arithmetic series is 19, and the 23rd term is 61. Okay, so we've been given two equations that we have to generate. So T17 is equal to A plus n minus 1d. So if you think about 17 minus 1d, that's the same thing as 16d. And that is equal to 19. Whereas the 23rd term is equal to A plus 22d. So we're doing 1 less than 23. Then this is equal to the number 61. So we're at equation 1, equation 2. I generally like subtracting the larger coefficients but the small ones. So I usually do equation 2 minus equation 1. So if I get everything here minus by everything here, A minus A is 0. 22d minus 16d is 6d. And 61 minus 19 is 42. That leaves us with 6d is 42. So d is 7. Okay? But we're not done yet because it's asking us to find out the first term. So we sub into 1. And if we sub into 1, then A plus 16 times 7 equals to 19. Right? So 16 times 7 is 112. Okay, and subtracting that over, A would give us negative 93. Then we're being asked to find the sum of the first 10 terms, so S10. Okay, let me just get my formula down. Here we go. Right, so if I'm finding this first 10 terms and finding the sum of them, do I have the last term, which is the 10th term? I have no information about that here, about the 10th term. So I can only use this formula here. So S10 is going to be 10 over 2, 2 times A, which we found was negative 93. And then we're going to add that with n minus 1, which is 10 minus 1, which is 9, times 7, which is our common difference. And in our calculators, that should give us negative 615. Question C. Let's find out the first positive term. Your first positive term requires you to know what your term formula is. Okay? So your term formula is this. you can simply substitute in these two values here, which are negative 93 plus n minus 1 times 7, and simplifying that will give us negative 93 plus 7n minus 7, so Tn is 7n minus 100, and we're trying to find out the first positive term, so we're going to get this term formula, and we want this to be greater than 0. So moving 100 over will get us 7n greater than 100, and if we divide both sides by 7, n will be greater than 14.2, and so on. So if we round this up to the next number, we'll get n as the 15th term. And so they're looking for the 15th term. The 15th term is the first term that is a positive term that's bigger than 0. So we set this back into this formula here. We get 7 times 15 minus 100. And that should give you the number 5. So the first term being greater than 0, okay, is the 15th term, which is number 5. And again, here is your homework that you're going to do after your trials. Right, that's it I'll do for today.